So, good day guys. Our next topic is permeability. Okay, so references natin same, pa rin yung tatlo. And then, so let's begin. Soils are permeable or meaning nagpa-pass through yung water or fluid or liquid due to the existence of interconnected voids. So, of course, may mga voids dyan through which water can flow from points of high energy to points of low energy. The study of the flow of water through permeable soil media is important in soil mechanics. It is necessary for estimating the quantity of underground seepage under various hydraulic conditions, for investigating problems involving the pumping of water for underground construction, and for making stability analysis of earth dams and earth retaining structures that are subject to seepage forces. Okay. So maraming applications din ang permeability and it's one of the basic parameter din yung coefficient of permeability or hydraulic conductivity ng soil. So one of the major applications nga ay yung slope stability analysis ng earth dams. So yung mga dam, okay, and then also yung mga levee o yung mga tinatawag na flood mitigating structures. Like yung kung nadadaan kayo sa Binangonan, 'di ba merong ano 'yon, merong Pasig ba 'yun or merong ano mahabang uh, flood protection doon na daan siya or road papuntang Binangonan. So 'yun. Ano 'yun, meron siyang kailangan doon ng slope analysis. And then kailangan ding malaman yung seepage forces kasi merong ano dun may water may body of water din kung magsisip pa yung soil underground. Yun. And then also for temporary dams like sa mga or tag doon yung protection para sa mga projects na may underground or may groundwater. Okay. So kung mataas yung groundwater table and then maghuhukay ng foundation, so kailangan mag-pump out ng water. So yun. Yun ang isa din sa mga applications ng permeability or ng concept ng permeability. Basically yung permeability nagfa-follow din ng mga principles ng fluid mechanics. So number one, principle kasi ng fluid mechanics ay related to flow of water is the Bernoulli's equation. So H meaning the total head in terms of meter or feet is equal to the U over gamma water. U means pressure and this term is what we call the pressure head. And then we have velocity head, V squared over 2G, where V is the velocity of the water and G is acceleration due to gravity. And Z is for the elevation head. In soil mechanics, we often neglect the velocity head or the effect of the velocity head. Bakit? Kasi sobrang bagal ng flow ng water sa soil. So, almost negligible na yung effect niya, yung head, due to the velocity. So, yung H o yung head difference ay nagmumula na lang sa elevation head and sa pressure head. Okay, sa pressure na for example, may seepage pressure and sa velocity head dun sa height. From one point to another, so yung difference in elevation, that would be the difference in head due to elevation. Yan. So, this is a schematic diagram. So, kung paano nagfo-flow ang water. So, kung kukuha tayo ng isang strip or ng isang soils, magko-consider tayo ng isang part ng soil sa ilalim ng lupa na may flow ng water na nangyayari. So, ito yung inclination yan. Naka-incline siya. Then we injected two piezometers. So, ang tawag dito ay piezometric pipes. So, pagka nagsaksak ka ng piezometer kasi sa isang aquifer, so for example, this is an aquifer. So, may tataas na tubig dyan. So, ang ibibigay sa'yo nun ay yung total head. or yung head from a datum. Okay. So this point A, may total head siya na HA. And then ang nagko-contribute sa total head niya would be the pressure head and the elevation head. Okay? So from here up to here, yun yung tinatawag na elevation head, and then yung pressure, kasi may flow yan eh, 'di ba? Nagpo-flow yung water. So from the fluid mechanics, may pressure. Lalo kung underground yan. So kung groundwater aquifer to, and then yung may soil, and then merong mga voids dyan. So nagpo-flow yung water, may pressure. So pag sinaksak mo yung piezometer dyan, so from here up to this, so yan yung water level niya. Yun yung tinatawag na pressure head, energy head, or head sa point A. And then if we inject also another piezometer at point B, so ito yung elevation head niya, and then ito yung pressure head niya, and then total head niya ay ito. And then the length of the soil parallel to the flow from point A to point B is L. So take note of that. Hindi pwedeng ito hanggang doon. Hindi ganoon ang pagsukat ng L or ng length of the soil in terms of permeability. So lagi yung length nung the distance between 2 points with respect to or parallel to the flow. So kung naka-incline yung flow, that naka-incline din yung L mo. So yan. So ito yung difference between point or the distance between points A and B. Ayun, the length of flow over which the loss of head occurred. And then kung mapapansin nyo, yung head o yung elevation o yung yung head ay mas mataas sa letter A kumpara sa point B. Ibig sabihin, mas mataas ang energy kay point A than kay point B. So, syempre naman, kasi, paano mo malalaman kung alin ang mas mataas? So, you would check the flow. So, titignan nyo yung flow, kung papunta doon. Normally, from point A to point B, mataas yan. Pero, i-consider nyo rin yung elevation head. Baka naman, for example, pag ganito nga yung flow, pero mas mataas pala yung elevation head ni point B. So, pwedeng magkaroon ng difference in head or energy head. Okay, so so kino-compute yan using fluid mechanics. Okay? But in this case, ganito yung flow, and then mas mataas si A kay B. So, ang elevation head difference, so mas mataas ang energy kay A papunta kay B. Okay, so yan. And then, meron tayong tinatawag na hydraulic gradient. So, it is the ratio of the head loss, or the difference between the head from point A to point B, and the length of the soil sample. Yan. So, delta H over L. So, ang tawag dyan ay hydraulic gradient. So, ito ang pressure, elevation, and total heads for flow of water through soil. So that's for Bernoulli's equation. And then another principle na apply natin sa soil mechanics or sa permeability ng soil is the Darcy's law. According to Darcy, the velocity or the discharge velocity is proportional to the hydraulic gradient. And the coefficient of proportionality is what we call the hydraulic conductivity, or otherwise known as coefficient of permeability. So letter K ang designation niya. So, ang sabi ni Darcy, the discharge velocity ay may kinalaman sa hydraulic gradient. So, delta H over L. Pwede rin ganyan. V is equal to K delta H over L. Yan. So, discharge velocity, which is the quantity of water flowing in unit time through a unit cross-sectional area of soil at right angles to the direction of flow. So, the discharge velocity is always right angle or perpendicular or normal to the direction of flow. So, yan yung discharge velocity. Yung cross-sectional area ay perpendicular or normal or a right angle with the direction of flow. On the other hand, meron din tayong tinatawag na seepage velocity. So, Q means the discharge, Diba, from our fluid mechanics, the discharge is equal to the velocity times the cross-sectional area. So velocity is meter per second and the area is square meter. So it would give you a discharge or a Q of cubic meter per second. So the discharge is equal to the discharge velocity times the cross-sectional area. And it is also equivalent to the area of the void in the cross-section of the specimen multiplied by the seepage velocity. Yan, so equivalent sila. On the other hand, another relationship of the discharge velocity and the seepage velocity is seepage velocity is equal to the discharge divided by the porosity. Kasi diba, the porosity is a function of the voids, diba? Volume ng voids over total volume ng soil. So yan yung relationship nila. Pwede ring ito. Kasi itong ano na to ay 1 over n. Then pwede rin ito. Okay. Then we now move to the hydraulic conductivity or the coefficient of permeability. So the hydraulic conductivity of soils depends on several factors. So maraming ang hydraulic conductivity kasi is unique to every type of soil. So kung meron kang soil, ano siya depende siya sa soil. So yung hydraulic conductivity na for example ng isang sand sa isang particular na lugar ay meron siyang sarili niyang hydraulic conductivity. Ganon din sa iba. So parang identification nila yan. So ang mga factors na nagkaka-apekto sa hydraulic conductivity ay number 1 is the fluid viscosity. So ito normally naman water lang ang nagsisip through the soil. Kung merong iba, pwedeng seawater kung medyo malapit sa dagat. And then kung for example, sanitary landfill, so iba ang viscosity ng ng lishit or nung mga katas nung basura or nung mga nabubulok na so may mga katas yon. So pwedeng maiba yung viscosity. And then pore size distribution, and then grain size distribution ng soil, void ratio, roughness of mineral particles, yan. So yung mineralogical composition ng soil. So meron kasing mga soil samples na rough, merong smooth. So pag rough, mas mabagal. Pag smooth, mas madaling mag-flow ang soil. And then degree of soil saturation, yan. In clayey soil, structures play an important role in hydraulic conductivity. The value of hydraulic conductivity varies widely for different soils. Some typical values for saturated soils are given in Table 7.1. The hydraulic conductivity of unsaturated soils is lower and increases rapidly with the degree of saturation. Yan. So, syempre, hintayin pa kasi maging saturated bago mag-flow ng mas maganda or dire-diretso yung soil. So, ganun ang ginagawa sa mga tests. So, ito yung typical values of hydraulic conductivity of saturated soils. So, clean gravel, 100 to 1 cm per second. Coarse sand, ayan. So, mapapansin nyo, habang lumiliit or nagiging fine yung particles, mas bumababa yung hydraulic conductivity or yung coefficient of permeability. So, mas nahihirapang mag-pass yung soil o yung water through soils. Yan. So, laboratory determination of hydraulic conductivity. So, we are now in the determination of the coefficient of permeability. So, there are two. Number 1 is the constant head test and the other is the falling head. So, ito yung ito yung formula, 'di ba? Ito ay anong tawag dito? Continuity equation. So Q or the discharge is equal to the area multiplied by actually yung Q dito ay volume Kasi yung time andi dito. 'Di ba? Q or the discharge, yung small letter Q is cubic meter per second. So, pag volume lang, yan, Q ang notation doon sa book ni Braha M. Das. So, Q is equal to A times the discharge velocity times time, where A is the cross-sectional area of the soil specimen. So, ang cross-sectional area, for example, ito yung ano. So, kung bilog itong permeameter mo, so, yung cross-sectional area niya ay ito. Yan. Dapat perpendicular dun sa flow ng water. And then, yung velocity, ayan. So, velocity according to Darcy is K times I, diba? And then, yung time, so, ilang seconds or ilang oras ka nagkolekta. Kasi merong ano dito ilang oras yan. So, yan, constant head. Ang ibig sabihin ng constant head, guys, di ba, ang head kasi ay, eto, from here hanggang dito, na-maintain yung head. Sabihin, ito yung pressure na nag-a-act dito sa sa soil. So, hindi siya nagbabago, hindi siya bumababa. Kasi pressure is dependent to head So, constant head or constant pressure, parang ganun. And then, constantly nagfo-flow yung water dito. And then, merong porous, may porous stone dyan. And then, andito yung soil specimen mo. And then, yung length ay mula dito lang hanggang dito. So, hindi kasama yung porous stone. Okay. And then, yan. Magpapatulo ka lang dito. And then, yung mga sasobra, tatapon. And then, ayan. Dito yung magfo-flow dito yung water na nag-pass dun sa soil. Actually, wala palang tatapon dito. Na-maintain lang yung yung head. Yan, then kokolektahin mo lang yung tumatapon na volume of water. Yan, ibig sabihin, yan yung volume na nag-pass through na dito sa soil sample. So, yan, and then, how much time is needed para mag-pass through yung ganitong karaming soil ganito karaming water dito sa soil na ito. And then, we have the equation, i-arrange nyo lang to. So, K, or the hydraulic conductivity of the soil using constant head, is equal to the volume times the length of the soil specimen over the area, or cross-sectional area of the specimen, times the constant head, times the time of collection. And then, ito naman yung falling head. So, meron kang i-introduce na standpipe. So, nandito yung water. So, may tubig dyan. And then, ayan, ito, may tube dito, papunta dito. And then, may tumatapon. May kukolektahin ka din dito. Ito naman, ibig sabihin ng falling head, yung soil mo kasi, yung water mo, from this head, bababa yan, bababa yung water kasi magsisip siya dito sa soil. Okay? And then, kapag bumaba yung water, yung bumaba na water na yun yung lalabas din dito, di ba? So, yun. So, ganun siya. So, Q or yung flow rate or the discharge rate, and then, in terms of cross-sectional area ng standpipe, and then, cross-sectional area of the soil specimen din. Yan. So, ito yung Darcy's law, di ba? Q is equal to K. Ito yung I, or the hydraulic gradient, and then A, yung soil. And then, ito ay equivalent sa negative A, or the cross-section of standpipe, multiplied by the change in height with respect to time. So, change in height meaning, kung anong oras nag-start yung test, hanggang sa, kung anong oras, or kung hanggang saan mo siya patatapusin, or kung hanggang siya bababa. I-record mo yun. Normally, ginagamit to sa mga fine-grained soil. So, kasi medyo matagal tong test na to So, inaabot to ng araw. Pagka sobrang pa nung soil sample mo, sobrang compacted and sobrang So, matagal tong test na to. Iniiwan to Yan. So, yan. Using integration, di ba ito, meron kang derivative dito. So, pag in-integrate mo yan, ito ang lalabas. So, the hydraulic conductivity of the soil is equal to 2.303 times the area ng standpipe, times the length of the specimen, all over the area of the soil specimen multiplied by the time, kung kailan kung kailan nag-drop yung water sa standpipe from H1 to H2. Right? Yan. So, let's have some examples. Madali lang yan. Madali lang to. Diretso lang sa formula The results of a constant head permeability test for a fine sand. So, by the way, yung constant head, normally sa fine sand ginagawa yan. At mabilis lang. Having a diameter of 150 mm and length of 300 mm are as follows. So, constant head difference. So, meron kang yan, yung constant head, yung H. Time of collection, yung T. Volume of water collected, ito yung Q. And then, temperature of water is 20 degrees. 24 degrees. So, ayan, kinukuha din kasi to. So, iba kasi ang viscosity or yung pag-ano ng flow ng water at different temperature. So, syempre, kapag ka medyo malamig, di ba, medyo nagsolidify na yung soil or yung viscosity niya, medyo mas mahirap na siyang mag-flow.
Hi, sir. Good afternoon. Si Ma'am Alex na magiging nurse niya. Ano po?
Yan, so, para sa recording, para sa solution, sorry, recording. Nagre-record kasi ako. So, para sa solution, for constant head permeability test, so, ito yung formula, then given, ayan, yung mga given, and then, yan, convert lang, then, apply yung formula, and then, we get the hydraulic conductivity at 24 degrees Celsius is 3.96 times 10 to the negative 3 cm per second. Para ma-convert mo yung 24 degree into 20 degrees Celsius, so we use this formula. K at 20 degrees Celsius is equal to K24 and then, ano ba itong Greek letter na to? Yan, nu, yata yan, and then nu 20. So, ito yung table. Ano ba siya? 24 is 0.991. Yan yung N24 over N20. Yan. So, ito, 0.91. Then, multiply mo lang yung hydraulic conductivity ng 0.91. So, ano napansin nyo? From 24, pag binabaan mo siya ng 20, bababa din yung hydraulic conductivity, di ba? Yan. So, yes. Yan. 3.6 times 10 to the negative 3 cm per second. Yan yung hydraulic conductivity. Another one, for a falling head permeability test, so the following values are given. So, length of specimen, 200. Ito yung L. Area of soil specimen, 1,000 square millimeter, or this is the A. Area of standpipe, small letter A, 4 square millimeter. Time at 0, and head difference is 500, and then after 180 seconds, 300. So, bumaba siya ng how much? 200. So, determine the hydraulic conductivity of the soil. Yan. So, you just input all the values in this formula and then check the units. So, ito ay in millimeters and then your answer must be in cm per second. And then, for the falling head, another example is the falling head. Yan. The following are given. Then, yan, may drop na 25 to 12 inches in 8 minutes. So, yan, 25 over 12, then 8 times 15. Ang hinahanap dito ay area ng standpipe. So, yan, 0.15 square inch. Another example, ito hindi na to sa laboratory test, so ito ay in actual. So find the flow rate in cubic meter per second per meter length at right angles to the cross section shown through the permeable soil layer shown in figure 7.9. Given H 8, H1 3 meters, small letter H 4, S is 50 meters, and alpha is 8 degrees, and K is 0.08 cm per second. So, we're looking for Q, or the flow rate, in 1 meter length. So, formula, ito ay formula ng hydraulic gradient, letter I is equal to H over S over cosine alpha. So, kapag naka-inclined yung soil, so ito ang gagamiting formula sa pagkuha ng I. So, ito kasi, yung S, dapat ito ang kuhanin eh. So, ganun lang naman yun. So, you don't need to memorize this. Q is equal to KIA is equal to, so yung K, H cosine alpha over S, hydraulic gradient. And then H1 cosine alpha times 1. Bakit 1? Kasi 1 meter length. Ito, meter length, 1 meter length. And then cosine alpha is 8. And then yung H1, so ito. So, ibig sabihin, yung cross-sectional area ng flow ay dapat yung perpendicular sa flow. Okay. And nakita nyo, ito ay hindi naman perpendicular. So, kukunin mo pa yung nakaganon. Okay. So, pagka naka-inclined yung ano natin, yung flow, ang kukunin natin is yung perpendicular area. So, kaya H1 cosine alpha siya. And then, we get the value of Q, 0.19, 10 times negative 3 cubic meter per second per meter strip of the, or per meter length of the soil given. Okay. So, we now move to the relationships for hydraulic conductivity in granular soil. So, maraming researchers ang conduct ng study nila sa iba't ibang klase ng soil para makuha yung hydraulic conductivity ng mga soils in terms of other soil parameters na mas madaling kuhanin. Kasi mahirap mag-conduct ng hydraulic conductivity kasi matagal, mahirap i-prepare, yan. And then, so nagbigay na lang sila ng mga relationships. So, pwedeng gumawa ka ng ibang test like particle size distribution para sa grain size analysis. So, pwede yon, and then apply mo na lang yung mga relationships na ginamit ng mga researchers. So, some of those researchers ay ito. Ito ay for granular, meaning mga sand and gravel. So, kay Hazen in 1930, sabi niya, the hydraulic conductivity in cm per second is equal to C, or a constant that varies from 1 to 1.5 times the effective size in millimeter raised to 2. Okay, so yan, very simple. So, merong application ng D10 or the effective size in terms of hydraulic conductivity. Sometime in 1956, 1927, 1838, Kozeny-Karman equation. So, K is equal to 1 all over the shape factor times the specific surface area square times the tortuosity of flow channels multiplied by gamma W or unit weight ng water all over the viscosity of permeant. Okay, and E cube or the void ratio divided by 1 plus E. So, ito naman, halos lahat naman to ay constant. So, ito lang ito lang kailangan mong kuhanin yung void ratio ng soil or yung kailangang i-prepare. So, pwede mo naman kuhanin yung in situ void ratio niya. Yan. So, pwede siyang isang malaking constant na lang ito. Yan kasi mga to ay constant. Yan. Kaya pre-propose ni Carrier na gawin na lang ganito. K is directly proportional to E cube over 1 plus E. So, sinuportahan niya yung study ni Kozeny-Karman. Ni Kozeny and Karman. So, yan. Nag-propose din siya ng sarili niyang pero pinahaba niya lang. So, D ng larger sieve at saka D ng... So, ito ay with respect to the grain size distribution. So, kung meron kang grain size distribution, magagamit mo tong equation na to. Kasi ito ay grain size distribution. Ayan. So, may naman tayo mamaya. Pakita ko sa inyo sa example. So, ito si Chapius in 2004. So, 2.4622 multiplied by effective size din. Void ratio din, and then meron lang siyang constant na in-introduce 0.7825. And then si Amer and Awad in 1974, so yun din, E cube over 1 plus E. Then meron kang effective grain size, and then may CU, then may constant. So let's try an example. So the hydraulic conductivity of a sand at a void ratio of 0.8 is 0.047 cm per second. Estimate its hydraulic conductivity at a void ratio of 0.5. So gagamitin natin yung relationship na patunayan ng mga researchers. So yan. So K1 is equal to yan. So ito yung, 'di ba yung sabi E cube over 1 plus E. So, for the initial void ratio, and then for the second void ratio or the final void ratio. So, from 0.8, hahanapin mo sa 0.5. So, apply mo lang yan, and then K2. So we have this K2, 0.014 cm per second. So ano napansin nyo? Mas mabilis ang soil, ang permeability or mas mabilis mag-pass ang soil pag mas mataas ang void ratio. Kasi maraming voids. Pero yung compacted or yung konti lang or mas mababa ang voids, so mas matagal ang pag-pass ng soil, mababa ang permeability. Another, so ito yung kay, sino nga ba yun? Yung may DLT tsaka SF, LF tsaka SF. Yan. So yan, may particle size distribution, and then yan, fraction ng 2 consecutive. Yan. So the grain size distribution curve for a sand is shown, 7.11. Estimate the hydraulic conductivity using equation 7.30. The void ratio of the sand is 0.6. And then SF is 7. Okay, so ang gagawin nyo dito, kukunin nyo yung ito yung formula, 'di ba? F1 is equal to DLF raised to 0.404 times D sub SF raised to, or the smaller sieve raised to 0.595. So ito, tingnan nyo to, 'di ba ito 4 o yung difference nila. So yun. And then ito yung dalawang sieve. So pinag-minus kasi yung yung percent passing, 'di ba? Ito 196. So pag minus mo sila 4, ito ganun din. 96 minus 84, 12. 84 minus 5 is 34 and then 50. Then ayun, yung difference lagay mo diyan, and then kung ano yung dalawang sieve na pinag-minus mo, kuhanin mo yung sieve opening nung dalawa na yon. Lalagay mo dito yung malaking sieve, lalagay mo dito yung maliit na sieve, yung opening. Then may makukuha kang value. Ganon din dito. So, yung 12, etong dalawa yon, 0.0425 and 0.02. And then, ayan. And then, kukunin mo ngayon yung summation nung mga ito. I think para dito yan eh. Yan. So, meron ka nakuha ang summation and then, i-apply mo ngayon to sa formula na ito. Yan. Ito lang naman na mahirap dyan. Then, yung shape factor or yung SF, 1/7 squared, nasa formula din. Then, 0.6 ay yung void ratio. And then, 1.99 times 10 to the 4 ay, saan ang galing to? I think constant yata ito. So, wala siya eh. Constant yata sa formula. Okay, so, yan. Ang nakuhang hydraulic conductivity is 0.0097 cm per second. Yan. So, for cohesive soils naman, ibig sabihin ito yung mga medyo fine-grained, yung mga clay. So, number 1, ang sabi ni Taylor, log K is equal to log K naught. K naught means the in situ hydraulic conductivity at the void ratio of E naught, or the initial void ratio. And then, hydraulic conductivity at the void ratio E. Yan. And then, hydraulic conductivity change index. Yan. So, meron kang graph na pwedeng gamitin. So, doon mo kukuhanin yung mga values nitong CK. Okay. Yan. Then, si Mesri and Olson, 1971, log K is equal to A prime log E plus B prime. Then, A and B are experimentally derived constant. So, may gagawin ka pang experiment para magamit mo ito. Then, si Marasinghe et al. In 1982, K is equal to C, then meron siyang constant na N. So, parang same siya nung mga nasa coarse grain soil, diba? Yung E raised to 3. Pero ito, may constant siya na C at N. Yan, so, halos similar sila. Yan. For a normally consolidated clay, so clay to fine-grained, the valuing values are given. Yan, void ratio 1.1, ganito ang K niya, and then 0.9, ganito ang K niya. Estimate the hydraulic conductivity at a void ratio of 0.75. Use equation 7.38. Or yung kay Samara Singhe hata ito. So, K is equal to C. Yan yung formula niya. So, since nagbigay siya ng dalawang dalawang K. So, pwede mong gamitin yan dito. And then may actually two unknowns. Unknown yung C at unknown yung N. And then, meron ka namang given. Given naman yung K. So, actually, pwede mong ilagay dito yung isang K dito. And then, ilagay mo dito yung isang E corresponding to that K. And then, first equation mo yon. Then, another equation ay ito naman, lagay mo dyan. So, ganun din yun. Parang two equations to unknown using algebra. You can solve for C and N. Yun. N at saka C. Then, pag nakuha mo na yung N and C, gamitin mo ulit yung equation na to. Yan, like this one. And then, substitute mo ngayon yung value ng void ratio na pinapahanap yung hydraulic conductivity. Then, you will get 0.514 times 10 to the negative 8 cm per second. Okay, so, ganun lang siya. Okay, so for equivalent hydraulic conductivity in stratified soil, so stratified meaning layered yung soil. So there are two cases. Number one is kapag ka yung soil mo, stratified siya ng like this one, naka-horizontal, and then yung directional flow ay horizontal. So the direction of flow is parallel to the stratified or the layers of soil. So yan, may kanya-kanyang height yan, and then may total height. And then, meron silang kanya-kanyang hydraulic conductivity, horizontal and vertical. So, magkaiba kasi ang hydraulic conductivity ng pa-horizontal and pa-vertical eh. So, yun. Maraming kasing factor na pwedeng, like yung gravity, di ba? Gravitational, So, pag vertical, may effect yun. Then sa horizontal, meron din. Pero, yan. Magkaiba sila pagka tinest mo yan. And then, dito kasi sa layered soil na horizontal or parallel ang direction ng flow. So, tawagin natin tong horizontal flow in stratified soil. Ang constant dito ay yung I or the hydraulic gradient. Bakit? Kasi pag nagsaksak ka ng piezometer dito, sa part na to, yung head na makukuha mo ay equal sa lahat ng layer. Okay? So, equal. Pero yung value ng Q or ng velocity, hindi equal. So, iba yung velocity dito, iba yung velocity dito, or yung discharge dito, discharge velocity. So, syempre, mas mabagal yung pag-discharge pag-discharge kapag permeable ay pagka clay yung soil or pagka fine or pag mababa yung void ratio. So, yan. Ang equivalent hydraulic conductivity ng soils, parang ang ginagawa kasi dito, meron kang layered soil, so i-convert mo siya into one soil lang. So, kinukuha mo lang yung hydraulic conductivity to simplify. So, KH equivalent or horizontal is 1 over H multiplied by KH1, H1 plus KH2, H2 and so on. Yan. So, kukunin mo lang yung summation ng KH. For the vertical stratified soil, vertical flow in stratified soil. So, ito yung stratified soil, nakahiga sila. And then, yung direction ng flow ay pataas. Or pwede rin pababang ganyan. Basta vertical, perpendicular yung layered soil sa direction ng flow. Dito, ang constant naman ay yung value ng Q or ng velocity, discharge velocity or ng discharge. Bakit? Kasi yung soil na papasok dito, yun din yung papasok dito at lalabas dito, papasok ulit dito, lalabas ulit, then papasok dito, lalabas. So, equal. Equal ang Q or ang discharge. Therefore, equal din ang V. Kasi 'di ba Q is equal to V times A. But the hydraulic gradient is different. So, mula dito sa baba, kung magsasaksak ka ng piezometer, kung maglalagay kang piezometer, sa mataas yan, ibig sabihin mataas ang pressure dito, then kung dito naman, pababa ng pababa yan. Okay. So, ganun din sa, yan, so, baba ng bababa yung head. So, kakaiba sila ng hydraulic gradient. And so, ito yung ito yung K vertical flow equivalent equals H all over H1 over K vertical, H2 over K vertical 2, H3 over K vertical 3, Hn over K vertical n. Summation mo lang yon, and then you will get the value of the hydraulic conductivity in vertical flow. So, example, in 7.21, it shows 3 layers of soil in a tube that is 100 by 100 in cross-section. So, water is supplied to maintain a constant head difference of 300 meters across the sample. The hydraulic conductivities of soils in the direction of flows through them are as follows. Okay, so yan, may nagsusupply ng water and then may tumatapon. So, may nagpo-flow na water and then meron kang head difference. Ayan. So, ang question is this horizontal or vertical stratified, vertical flow? So, ito yung soil and then ito yung flow mo and then yung stratified mo stratification mo ay vertical, di ba? So, una muna dito, then papasok dito, then papasok dito. Then, yung discharge mo is equal. Kung ano yung pumapasok dito, yun din papasok doon, yun din papasok doon. So, yan. So, this is a vertical flow. So, gagamitin natin formula. Ay, ito. KV equivalent, H over H1 K1, H2 K2, H3 K3. Okay, then apply mo lang lahat nung parameters kasi given naman lahat. So, ano yung total H? So, yun yung mula dito hanggang dito. So, yun yung total H or height ng soil. Then, H1, so ito 150, lahat naman pare-parehas. Then, K1. K1 means K or yung hydraulic conductivity ni soil A or soil 1 which is 10 to the negative 2. Yan. And so on. So, may makukuha kang KV equivalent na 0.001213. So, ayun yung K. Ang pinapahanap ay discharge, right? Find the rate or the discharge. So, discharge is equal to Q is equal to KIA or KIA. So, yung K equivalent multiplied by the hydraulic gradient. Okay, so ano ang hydraulic gradient natin? So, di ba ang constant head na hydraulic gradient is, ayan, dito hanggang dito. Ayan, so yung dalawang water level, yun kasi ang head na tinatawag yung dalawang water level. Ayan, so ayan yung constant head. 300. And then, length ng soil sample is 450. And then, area ng soil specimen is 100 over 10. And then, 100 over 10. Kasi it kinonvert yata ito sa cm. Kasi 100 mm to eh. Yan. Area ng, cross-sectional area ng soil. And then, we got 291.24 cubic centimeter per hour. So, refer to example 7.15 and figure 7.21. Determine the magnitudes of HA and HB. So, pinapakuha naman ngayon ay yung piezometric head sa point A at sa point B. So, yung nakita natin piezometer kanina. So, the loss of head during the flow through soil A can be calculated as, yan, so, yun din, apply din natin yung KIA. Pero ang gagamitin natin K ay yung K ni soil at yung, ayan, I and then yung A. Ay yung cross-sectional area ng soil. And then, where delta H and L are respectively the head loss in soil A and the length of soil A. Okay. So, yan. Ito siya. And then, for example, 7.15, Q is equivalent to yan. So, nakuha na natin yung value ng Q, di ba? Or ng discharge. So, pwede natin siyang i-apply dito. And then, alam naman na natin si K, alam na natin si A. And then, we can get the delta H. Similarly, for soil B, ganun din. So, the discharge is the same. Di ba? Di ba sabi ko naman sa inyo, pag vertical is constant ang discharge. So, yan. Same lang yung discharge na ginamit. Pero, yung length ng soil B ay 15. And then, yung hydraulic conductivity niya is 0.003. And then, yung A ay 10 by 10. And then, yan. Delta H. And then, yeah, you do the math. 300 minus delta H minus delta HB is equal to 300 minus 12.14 minus 40.45 is 247.41. Yun yung HB. Hindi ko pala nalagay dito yung hindi ko nalagay dito yung figure. Yan, so na lang, pakitignan na lang sa module. Yan, so malapit na tayong matapos pero meron pang dalawa. Ayan, yung permeability naman sa pumping wells. So ito ginagamit sa mga construction ng high-rise building na may deep foundation. Ibig sabihin, may piles o may pilote na gagamitin, kailangan hukayin ng malalim. Pag naman hinukay mo kasi normally or sometimes, yung groundwater table ay mataas. So, pagka naghukay ka, may tubig dun sa site mo. So, anong gagawin mo ngayon? Ipapump out mo ngayon yung water para makapagawa ka or makapag-construct ka ng foundation dun sa ilalim or dun sa building mo. So, to determine the coefficient of permeability ng soil na nasa pumping well, yan. So, kailangan mo magsaksak ng dalawang well na maliit dito, and then ito yung ang tawag dito ay test well, and then ang tawag dito ay observation, ito yung test well pala, and then ang tawag dito ay observation well na merong distance na R1 and R2 from the test well. And then and then meron tayong H1 and H2. So pwede mong ma-measure kasi yan yung head. So dapat alam mo yung datum mo o yung impermeable layer. Sabihin wala nang effect yung permeability dito. Hindi na magsisip yung soil dito. So kailangan malaman mo yon. Normally ito yung bedrock. Okay, so yan yung H1 and then yung H2. Then you apply this equation. Yan. So ito ay derived na. Pero merong procedure sa pagsosolve niyan. Okay. Pag naman yung yung pumping well mo ay confined aquifer, ibig sabihin nasa pagitan siya ng dalawang impermeable layer, yung soil mo. Like this one, ito yung soil or yung aquifer. Ito impermeable, ito impermeable din. So, ito naman ang magiging formula na gagamitin mo. Ganun pa rin yung mga parameters, R1, R2, H1, H2. And then, H is the height of or the thickness of the aquifer. Yan. So, yun. Madali lang naman yun. Ano mo lang doon sa formula. Okay. So, for the activity 5, so there are 3 problems I think to be submitted next meeting. Okay, ito. Turo ko lang sa inyo kung paano to isa-solve. So, a canal is cut into a soil with a stratigraphy or meron siyang layered soils as shown in E4.3, assuming that flow takes place laterally and vertically through the sides of the canal and vertically below the canal. So, ibig sabihin, ito yung canal, nagsisip yung soil dito or nag-permeate horizontally and then vertically pababa. Okay. Vertically through the sides and vertically below the canal. Determine the equivalent hydraulic conductivity in the horizontal and vertical directions. The vertical and horizontal conductivities for each layer are assumed to be the same. So, ibig sabihin, kung ano yung vertical, yun din yung horizontal conductivity. And then, calculate the ratio of the equivalent horizontal hydraulic conductivity to the equivalent vertical hydraulic conductivity for flow through the sides of the canal. Okay. Okay, so, ang first step niyan, kunin nyo yung equivalent hydraulic conductivity hanggang dito lang. So, meron kang 3 layers ng soil, 1, 1.5, and then para dito, meron kang 0.5. So, pwede mong makuha yung equivalent hydraulic conductivity para sa isang layer na to. Then, ayun na, meron ka na. And then, after nun, makukuha mo rin yung hydraulic conductivity nung buong system or nung buong stratified soil. Ang gagamitin mo lang na hydraulic conductivity para dito sa 3 layer na to ay yung equivalent horizontal flow hydraulic conductivity. And then, for the vertical flow naman, yan, so, di ba, andito kasi yung water, so magpo-flow yan pababa dito. Yan, so you can get the vertical hydraulic conductivity. Okay, so, yun. Ito lang ang kukuhanan mo. Ito, and ito. Kasi sila lang naman yung nasa ilalim ng canal. And then, you can compare the hydraulic conductivity ng vertical at ng nasa horizontal ng canal. And then, ito naman, okay, ayan, may porosity, so hydraulic conductivity and seepage velocity. And then ito, falling head test. Yan. So, apply lang yung formula sa falling head. And then ito, what you collected? Constant head ba to? Tama, constant head. Okay. So, prepare for a short quiz. Next meeting, problem solving type ng exam. Coverage, soil compaction, permeability, and seepage. So, kung may question, just ask. And, ayan, sasagutin naman natin yan. Okay? So, that's it for permeability and thank you.